So let's say this is a transaction 1 and running from t0 to time t whatever. Then in the meanwhile, in the middle of the transaction, there is another transaction to update the data. Update, suddenly the CEO announced that we are going to increase the salary by 10%. So, but right away. So this time, the 10, the update the salary by 10%. Okay, and it happened. So update, let's say it's a shorter than so this is a T1, so this is a T1, T2. What will be the output? This one. Is it based on the T0 or T10 or let's say this is a T100 or this is a 50? T0 supposed to be T0, but if you do not have such a solution, it's messed up. Some of them are updated, some of them are not updated yet. So we cannot guarantee. That is the issue without concurrency control. So we need to address how in real the DBMS, how does the real DBMS address such a problem? Any idea? Rollback. What is a? We didn't discuss the detail about the rollback. We will talk about it. But the rollback means going back. But we don't have to going back because
it does not allow an update under the transaction.
That's one way. But problem, a lot of loss happen. You need to get the lock when you access the data. Okay. Whenever you access data, you get the lock. What if it takes 1 year? So your entire system will be locked for a while. So that's a basic solution, but not very popular.
Call customer service.
Call customer service. So one of the way is in case the update, you can keep the version. Even though this is a commit here, before commit, anyway, the data is not changing, right? So you can handle that even though committed, if there is a transaction that started before that, you can still keep such a before image. Okay? Where? And certain part of the memory. Okay? Or sometimes it can be secondary storage. You need to keep the before image until all transaction which started before update. For this transaction, you can keep the before image, so you can use it. Problem? What if this update is huge? Okay? You need to keep the before image in the memory sometimes, or the disk, or after image. So it's huge. Sometimes the DBMS cannot keep all the image. Then what happened? DBMS announced, I'm going to give up. Then stop this process. For example, in Oracle, that's called the very popular 15555. I guess a snapshot to all. Okay? There are a lot of updates, but there are very long running query. So you cannot keep all the changed data. So DBMS give up. I cannot keep this data. The solution, you need to run it again. That is a very popular error message. So 15555. Okay. So this is the reason we need to do the some concurrency control that is based on the transaction. So also such a transaction will be used for. This is kind of the transaction failure. Your transaction will be stopped because of that. So you have such a issues. Then to address that, we are not going to discuss this detail of the recovery, but to restore, to handle such an issue, transaction by transaction, we need to have such the concurrency control, which is based on the transaction. What kind of a failure? your entire system may be crashing. Okay. Also, your transaction will be failed. Transaction by transaction will be failed. Okay. Some local error or exceptional error and any control issue or disk failure or the physical problem, whatever the problem, it will be handled by the transaction. Okay, so we can do that. So what is a transaction? We already discussed. So transaction has such a state. Always start with, because the transaction is not the physical operation, unlike the read and write. So instead, it's a we falsely announce this is a begin transaction. Then your transaction will be started. And transaction is a two-way. Commit means permanently apply. Okay. The avert means go back. At that time, roll back. Using before image, you can go back to the data. That is the transaction. Sometimes we can do the partially commit. Okay. Checkpoint. So, however, you may not see the begin transaction and end transaction when you are doing database programming, right? When you are using the SQL Plus or the SQL, the application or database program, have you ever seen the begin transaction? No, it's implicitly executed by your DBMS program or DBMS server. So SQL Plus, when you log on SQL Plus, so automatically begin transaction is started. And when you log out, it's a commit, either commit or the rollback. Okay, but you never type the commit. Some of the students, but I strongly suggest it depends on the default setting or configuration. So for your safety, you'd better explicitly submit the commit or rollback. Okay, so that is a commit transaction or permanently apply. And rollback transaction is a go back. I have a question. When you commit the data, number one is applied to the database hard disk drive. Number two, no, it's not applied to the hard disk drive. Okay, it will be applied later. Which one will be true? Second? First? Intuitively, it will be number one. But if the answer is number one, I may not ask. Right? It's a second. Even though you committed, it will not apply to the hard disk drive yet. As I said, transaction is a logical concept. It's logically applied to where? Cache, buffer. Okay? Why? What is the main reason? The using database system? Bunch of different reasons, but in my opinion, speed up, right? You want to access the data very fast, quickly, prompt response. So if you write the data hard disk drive directly, it will take a time? Yes, it takes a long time, okay? Instead, why don't you change the memory? Okay? Then if somebody want to access the changed data, they can get the data from the cache memory. So that makes the faster the database system. Problem. So before the problem, anyway, eventually such an updated data should be applied to the hard disk drive, right? So it's a delayed writing. When? Default writing or delayed writing. When? System is idle or either the process or system is not that busy time, you can write the data. Problem. This is the memory. What is the memory? Most of the memory is a volatile. Volatile means no power, no data. So what if you commit? So it should be applied permanently. But before writing, let's see, the heat unplug the power. Number one, you lose the data. Number two, you do not lose the data. What?
You lose the data.
If you lose the data, nobody uses the database system, right? But operating system, you lose the data. That is one of the reasons. For example, the USB, you need to confirm. Okay, that's kind of commit and apply to the permanent hard disk drive, your USB drive. But sometimes it's not applied. Okay, so because the writing is already done only in the memory. Okay, so but database, no, you should not do that. How can we guarantee such a change in data on memory? There will be another one that I'm going to introduce in this chapter. That is a log. Using the log, any action, okay, that you did in the database system will be logged, okay, or journaled. So for example, update, this command will be logged. When you commit, you do not apply the permanently in the hard disk drive, the update data, but you need to apply this command, okay, to the hard disk drive. So this is forever, even though power down, even though it's a crash or hurricane or the 9/11 bombing or whatever, it will be on the hard disk drive, okay, or backup. Then, what if the data is not applied? When they recover the data, recovery manager check the data. So for example, before it's a 1, after new one is 2. This one is still 1, but in the memory is 2. Update 1 to 2. System crash it. Then check this log data and this data. It's not matching. Supposed to be 2, but still 1. At that time, you can redo. That's the redo operation. There's another operation in database recovery. Okay? Redo. Sometimes opposite. So data, so 1, 2, but not commit yet. However, memory is limited. Right? We have a small size of the memory, small buffer. So when you update a huge amount of data, you cannot keep both before and after image. Right? So even though not committed, before committed, this data changes. Okay? In case the rollback, you can go back using the before image. But it's a before image 1, after image 2, but it's not committed yet. But system crashes. So this one's supposed to be 1. But it's a 2. At that time when you recover, there is no commit yet. Okay, but it's updated. So you can roll back. That is the kind of rollback, but it's called the undo operation. So there are 2 main operations in recovery. So redo means supposed to be changed, but it's not applied yet. So you need to redo operation. Another one is undo. Undo means it's not supposed to be the changed data, old data, original data, but it's changed. So you need to undo, go back the operation. So basically, we can use the transaction. We can apply the transaction concept to the database recovery, for redo and undo. So I a little bit explained about the thing, then you can easily understand it. So that is the undo and redo operation. Not easy, understand the first time. But think about the logically, how we can. So first, you should realize that you should understand why we need the memory. Memory is a cache, so for faster the processing. Then, however, memory is not permanent, it's a volatile. So how can we keep such a thing? Okay, using log, so data. So to do that, so in case something happens, we need to apply undo and redo operation. Yes.
And the DBMS, when we are using, like when we are executing a lot of transactions, of course we have some kind of queue structure.
Yes.
Right? So let's say that I have a simple database, like a customer and the producer, right? And like both of them, they are working concurrently.
Yes.
The customer is reading, and the producer is writing,
Okay.
right? So the customer is keep reading, right? And waiting for the producer to write data.
Yes.
And let's say that we can have like a synchronicity problem if the producer write and the customer is still reading,
Yes.
so it will be slow.
Yeah.
So can we just use a structure, like can we just make the customer wait or the producer wait until a data or like a resource is has been
offline?
written? Yes.
So it's a type of the level of the concurrency control, depending on how to lock. Anyway, without lock, so you cannot solve the problem of the synchronization. Okay? But it has a different level of the lock. We will see next week such a different level of lock. Basic idea is what? You can lock until you update the whole the data. Even you cannot move it, right?
Right.
Problem?
But like for example,
which industry?
Problem. Your system should be hang until all writing is completed.
so we can't use this type of queue.
Oh, you can use it. It depends on your purpose. For example, if your system is only single user use it, okay, and also your job is the serializer, okay, then at the time you can block all the access to speed up of writing. Then until you, once you finish the writing, then so several.
Yeah.
So it depends on. But however, banking transaction. So there is a lot of updating of the transaction table, customer table. How many new customer in Bank of America? Every second you have the new customer. No chance to access the data if you lock. Right? It depends on. So we will see such a locking problem, different level of the lock. Actually, the real DBMS has the many the levels of the lock, but we will see three basic level, conservative. There's another one, I forgot the name of it. We will see the next one. Okay, different level of lock. That's a good question. Okay, so this is the log. So we can keep basically log, keep such a transaction operation. Okay, then using that operation, we can recover the database. The system log has the transaction information. Start, begin transaction, and the action like the write, or read, or commit, or over that we have seen. Okay, that should be backup actually. If you want to restore, so for example, during the 9/11, all buildings are demolished, the collapse. So you lose all the computer server and hard disk drive. No way to recover. Right? You do not have the backup data. If you back up the data different site, then out of that World Trade Center, you can recover. Some of the company actually they did such a backup different location. After that, the IT company realized that's very important to back up different location. That is called disaster recovery. In case of not just a failure, like the hurricane, okay? The hurricane hit when? What's the name of the hurricane that hit a couple of years or several years ago here? Sandy. That actually the impact some of the company building, the water coming in. But if they back up the data to different location, they can recover. At that time, what we need to back up? Such a log information is the most important. Without log information, you cannot restore the database. That is the log. Okay. So that's the whole thing that I explained. So first writing a log is so when do you need to log? When do you need to write the log information into such a log? Just before commit. It's a commit means commit and with writing the transaction information to the log data. In other words, if you fail to write the log, okay, that means your commit is not complete. Your transaction is not complete. It's the aborted. Okay. So using such a log, so we can. So such a transaction has some property. It's called ACID, the property. A, atomicity, because it's a basic. Basic means the smallest logical unit. So if the transaction is failed in the middle, no apply. It's going back to the beginning because it's atomicity. Consistency, preservation, consistency means that we discussed about the database state. So if the transaction is completed, which means database state is from A to B. Okay, database state will be the changing. Okay, it's not the same; it's changing. So that is a consistency preservation. Isolation means, so in this case, so we have the two transactions. Transaction 1, transaction 2. Does transaction 2 affect the output of transaction 1? No. As I gave you the example, this the update is not applied to the. If applied, that will be messed up. What about transaction 1, reading? So such a reading of the data affect any of the transaction 2, you can still update because they are independent. That's called isolation. However, there are different levels of isolation. If you have very strict isolation level, which means if somebody read the data, you cannot update the data. What? In other words, if some of the transaction update the data, you cannot even read the data. Too strict isolation. So there are different levels of the isolation. Durability or permanent. This is an example. In case something happens, still durability is a permanent. You should have the, because of the transaction control, you can preserve such a ACID property. Nowadays, it's a very strong property. Nowadays, it's getting flexible. For example, big data system or the NoSQL database, you probably heard about that. If you do not know about the NoSQL or the Hadoop or the big data, I think at least you should know what's the meaning of that, okay? As a student of the computer science, right? So why don't you? And also, I'm offering such a course, at least 1 or 2 each semester. At that time, we will keep only the few of the such a property. Okay, so that is the transaction, and I'm going to skip the serialization. So serialization basically means it's a kind of scheduling to keep the such a ACID property transaction that we discussed. Depending on how to the schedule the transaction, it will be, you cannot preserve because the concurrency level is different, locking level is different, so you cannot keep such a certain level of the concurrency. So we need to schedule the running the multiple transactions. So that is called the serialization problem, or the schedule of the transaction, number of transactions. But I'm going to skip this part. Okay. First one. Okay. So then, for example, SQL to have the, if you can specify the different level of the transaction mode. Okay. So for example, read only or read write. Read only means so your transaction is only read. So it doesn't matter. Okay. It can be shown other transaction and so on. Okay. So it has a different level of the transaction level. Okay. I'm going to skip this part. Then the next class we will see how to as he asked, so how to the level such a concurrency control, which is based on the two-phase locking problem. Two-phase locking means there might be two phases. Okay, one is a locking phase, another one is an unlocking phase. So we will discuss about such a two-phase locking problem. Next week, the Tuesday. Any question? Okay, thanks so much. We will see the